Hello and welcome to CodeRage. My name is Robert Love, and today's session is called Rock Solid and Secure Communications. Honestly, I didn't come up with this title, but the goal of this session is to teach you a little bit about SSL and how you can use it to encrypt your communications in a safe way for all the various products that are out there that Delphi supports, such as EMS, DataSnap, REST web services, raw sockets, etc. And so with that, we are going to go into a little outline. We're going to talk a little bit about SSL and how it works as a protocol. Really not how it works, but more along the lines of what options might you need to choose within it. Then we'll talk about some OpenSSL and how certificates can work with OpenSSL. We're going to talk about SSL with Indy, and then we're going to talk about SSL with IIS, and then we're also going to talk about ISAPI configuration, because getting that wrong can also give you you'll have security issues there as well. And so it's important to note those things, and let's move right along. SSL or TLS has several different versions of the protocol. One thing you should note is sometimes, well, quite often SSL is referred to even TLS, even though, so they become somewhat synonyms. But the version number and the actual protocol names are slightly different. So initially we had SSL 1.0, never was released to the public because it was found to be vulnerable to attack. So ultimately, they came out with SSL 2.0, and as you can see, it's now vulnerable to attack, and is so vulnerable that you should never use it. And SSL 3.0 recently was, within about a year, was exploitable by Poodle, and it is also recommended not to be used. TLS 1.0 and 1.1, a little less than a year ago, were found to be also exploitable by Poodle. And Poodle is basically a downgrade attack. It basically says, hey, well, there's lots of different aspects of Poodle, but one of the things that Poodle does rely on is says, hey, we have a problem with this various protocol, and we, during connection, let's downgrade to a prior version because maybe the server or the client doesn't support it. Well, with that, there has been a new option that the client can send that's TLS fallback SC/SV, and that basically prevents the client from downgrading. Another option is to just not have your server enabled all of those options. So you could say, hey, with this server, I'm only going to use TLS 1.2. And in the OpenSSL example that I'm going to show in a second, that's exactly what I've done. I also wanted to point out that TLS 1.3 was just barely introduced as a draft standard. There's no, there's lots of negotiation and things that have to happen, and testing that will happen before that becomes an actual standard. But I wanted to point out that it's ever changing, and that you need to stay up on top of security, and that once you've implemented it does not mean that it stays secure, because there are new and interesting ways that people are always trying to exploit this. So with that, let's talk a little bit about what it depends on. Well, it depends on a certificate on the server. And it also depends on a key, that the server having a private key. And it also depends, although this is a little bit more implementation specific, on having access to the certificate authority's root certificate. This is to verify the authenticity of the server certificate. And you can also use client side certificates in SSL or TLS. And this is something I'm not going to cover today, but it is an option. It becomes a little bit more difficult to maintain because you have to control both sides of the equation, but it is very possible to do and very practical when you're in an enterprise environment and you need to control and secure two endpoints and verify that those two endpoints are truly who they are. So with Indy and OpenSSL, there are two DLLs here, you can see them listed, that are required for server or client side. So we have lib EA 32 DLL and SSL EA Y 32 DLL. So regardless of whether or not you're using building a client or a server or both, you'll need these DLLs to ship with your code. There are also versions of these that will go with the various mobile platforms, and so that's just an FYI. You can deal with that. They're not just strictly, it's a library. It's not just strictly a DLL. Servers require 3 specific files. When we're setting them up, we need the root certificate, the server's private key, and the server certificate. And although I've said it before, it's important to follow the software that you use, the security software. So in this case, OpenSSL, and update it when security issues are found. OpenSSL has had vulnerabilities, as is many other software packages. Windows, Mac OS X, Android, iOS, they've all had security vulnerabilities within them. And at any given time, there are published ones that are existing. So patching and making sure you're up to date is very important at all times. So let's talk a little bit about a self-signed certificate in OpenSSL. Why do we do that? Well, for one, it's a nice thing for development. It's easy to do in development. Another thing is, if you're in an enterprise environment, you might set up your own certificate authority. Or maybe, when I mean enterprise, really what I mean is you're building software that's in-house, that's never going to be consumed by the general public. So my enterprise could be 2 machines. Really, it doesn't matter. But with the security certificate authority, that has to be known to all the people who will consume you. So it's not or consume your service. And because of that, it doesn't scale to the public internet. And with that, you can purchase certificates to allow that to happen. And so that's just a general thought to consider here as you're going through this. So let's, when we go through and build an OpenSSL self-signed certificate, these are the steps that we kind of go through. First, we generate a private key. And after that, we use that private key to generate a certificate for that, the root certificate there. Then we generate a private key, and that's the server's private key. And that does not depend upon the certificate authority at all. And the server then sets up a certificate request. And the certificate request also does not depend on the certificate authority. At that point, with that certificate request, you can send that to the person who is running your certificate authority. So either the commercial entity that's doing it, or in your case of the self-sign, we will sign it ourselves. So with that, the server certificate is signed by that authority. And there are commands in OpenSSL to do all of those things. And let's go and show you how to do that right now. All right, so I've created a command file or a batch file that basically I call recreate keys, and it's going to walk through all the commands. I'm going to give access to this in the config file that it uses at the end of the session, and then you can use that as an example on doing the various commands, or just use it directly. And it'll hopefully simplify your life, because learning these commands can be a bit tedious. So we're going to say, do we want to recreate the keys? And this is great the first time, but be careful, you're creating the certificate authorities key as well, and you may not want the certificate authorities key to be deleted the second time around. So with that, you'll need to modify the script if you want to generate additional keys that are based on that same certificate authority. So in this case, I say yes because I do want to delete those, and it'll delete the old files if it can find them and go on. Now there's some instructions that come on the screen at any time, but what I want to point out is this OpenSSL command, which is gen RSA. So OpenSSL gen RSA -des3 -out, and then I pass a file name. And in this case, I'm calling it CA for the certificate authority .key.pem. And then I'm going to give it a key size. And so in this, it's 4096. I have to enter a password for this. So I'm going to enter that password. And then with that, it's a new password. So I just gave it that. Now we're creating that certificate request. So, or not certificate request, we're creating the certificate for the root certificate. So you'll see this OpenSSL request. And what will happen here is we just enter that password for the private key. And this is going to start asking some questions. And I'm just going to enter through these because it really doesn't matter for a developer certificate. I tend to put CA as the common name here and leave everything blank. At that point, we now have the need to create a private key for the server. So this is typically a different password than what the server has, so or what the certificate authority had. So we entered that in, and the other thing that should be noted is the key size is 2048 instead. With that, we get to create a certificate or request. So we need to do that, and we're going to enter the password for certificate request. And note that you need to make sure the country name is the same as the original request, or that won't work. And so we go through and specify each of these. The common name here is localhost, and I leave this blank. And now, with all of that, I now need to take the root certificate that I had and use it to sign the certificate request that we just created. And now it's requesting the password that we first gave. So there's two passwords, the one for certificate authority and one for the server. And we're asking right now for the one for the certificate authority. And with that, it's going to say, hey, this all looks good. Do you want to sign the certificate? And I can say yes. And one out of certificate request created. Do you want to commit? And I could say yes. And the database was updated. And ultimately, if I now do a directory in this file, I will see a whole series of files. I'll see localhost, PEM, and I'll see the certificate, PEM. The certificate authority key is highly secure. You should not distribute that, nor should you distribute the server's private key, except for in the place of, it should be on the actual server where the application is running. But the certificate authority key does not need to be anywhere near anything that you've ever done. And that's important. A bunch of files are created because it is a certificate authority that keeps the serial and the indexers that are used to keep track of future certificate requests. And so I just kind of keep all of that in mind. I know that's really fast, so hopefully you'll be able to go through the command file and look at each individual command. But it's an easy way to get this to work, and we'll go from there. Let's now go look at using this with Indy. All right, so what I have here is an Indy project that I've created. It's just a simple demo project, and it has both the client and server built into it. And you could keep them separate, but just for simplicity and navigation in the demo, I've put them together. TD, I started off by dropping down an ID TCP server component. and that's this component right here. And then I drop down an ID server IO handler SSL OpenSSL component. I also drop down an ID TCP client and an ID SSL IO handler socket OpenSSL component. And that's some big names there. But ultimately, there's a different handler that's specific to the server, and there's a different handler that's specific to the client. I've done nothing in the object inspector to these components. And the reason I did that is so that we could see it in code and understand it a little better, and make sure that we didn't miss anything. So with that, the button click that I have here to set up the server, we start off with the SSL options, and we need those 3 files that we just produced. So we have a localhost cert, which is the host, the cert file that we've generated, and the localhost key. And now that key is password protected, and so we'll need to supply that here in just a second. And the root certificate file is there. We also need to set the mode to server. And then we set the verify mode, and this is where we can say whether or not we want client certificates and verifying certain things as far as those certificate values. But we're setting it to blank and 0 because we have a self-signed certificate, and we're not trying to verify any of that or use client-side certificates. On the SSL version, however, we're using SSL TLS version 1.2. And so you can see that here. And then you can see the onGet password. If I look at that, it's just a method that says the password. And note, I've put in here in real world, you should never use a hard-coded password because you'd have to deal with it every time the cert changes. And like the cert that we're using now expires in a year. That would be a pain to deal with every time. So this needs to be separate as well. Another thing to deal with is on the TCP server itself, we have to tell it what port it's going to listen to. And so with that, I've specified the server port. That's just a constant above of a number. And then we have the TCP server is finally set up an IO handler, and that's pointing to the one we just set up above. With all ID TCP servers, we have to implement an on-execute event. And so with that, there's the server execute. And we'll just show you what that code is. Here, we say, hey, we're going to go out with the IO handler and write out, hey, welcome to the Echo server. And then while connected, it's just a local value here. We are going to keep looping. And we'll read a value, and when we get the results of that value back, we'll write it back out to them. And so basically, it's just echoing the commands that came in. And with that, we can move to the client side of the server. So we're just going to go in and look at this client side. If you're using signed certificates, you're going to, that are not self-signed, you're going to want to change the verify mode and depth. But just an FYI there. But in this case, we're not, so we're just leaving them blank. We also set this to TLS 1.2, and in this case, we really do want the SSL mode to be unassigned. With that, we're going to communicate to the local host. So I've hard-coded the local IP address and the server port, set a read timeout, although it's not really required, and we then set up that IO handler that we've had, and we call connect, and we read that result, that welcome message back. So with that, let's just run this. So if I click the setup server, and then I click the setup client, you'll now see that we're now connected to the Echo server, and I can say, hello, CodeRage X, and hit send, and you'll see the results of that. With that, it's simple, but how do I know that I truly was set up right? How do I know that? We're going to need to use some verification methods with OpenSSL. Okay, so what I'm going to do is just open up a command prompt here, and we're going to type in OpenSSL space s_client space -connect, and then we're going to specify our local IP address, :6050. And with that, I get a connection, and I'm able to look at all of the results. I can see that it got connected. I could see that it's a self-signed certificate in the certificate chain. That's fine. I actually get to see that certificate. I know that it was read. I can also see that TLS version 1.2 is the negotiated protocol, and the cipher suite, which is the underlying encryption that it will be using, is AES 256. With that, I now have my echo server, so I can come in here and also type in hello CodeRage X, and it will return that result, and then I can quit as well. So that basically shows a quick way to test, and this is really a nice way to make sure that when you're doing this, there's a lot of headache that gets involved with making sure that your client or your server is set up correctly, and having a tool like this is really useful to verify that the connection is set up correctly and it's not your code. That the server's working, because when you're dealing with client and server, I could have problems with the client code, or I could have problems with the server code, and this is a way to isolate that very quickly. There is also an s_server command, and you can also have it respond as a HTTP server, which is a quick way to test your client code. And at least see that, hey, I'm getting connected. Whether or not it'll actually communicate with the protocol that you're after is another story, but it at least does allow some isolation that way. Okay, so we've covered how to host something under Indy and deal with SSL there. Let's talk about how we can do it also under IIS. Under IIS, you have to start off by disabling some older protocols and cipher suites. This is important to make sure that it's secure, but you also don't want to beat it so limiting that you can't, you prevent a lot of clients, because you are dealing with now a web situation. And so we'll deal with that in here in a second. We're also going to talk about how to create a self-signed certificate using the Windows tools. You can also still create a PFX file from OpenSSL and import it in as well into IIS, but there's a little button that does it all for you, and so we'll show you that. And then we're going to talk a little bit about how to install an ISAPI DLL into IIS correctly. EMS, REST, DataSnap, SOAP, web broker, intraweb, most of all of Delphi's web solutions involve an option to produce an ISAPI DLL, and with that, or one's already produced for you. Anyway, with that information, the cool thing is once we show you how to do one, you'll be able to do them all. And let's move right on to how to disable the older protocols. Well, for one, it can be done through the registry, and there are plenty of articles out there on how to do that. But there's a lot of options there. Unlike your normal simple registry entry, there, getting the cipher suites correct and getting all the options right, the odds of getting it perfect are really hard. It's just going to be a little tedious. So what I would recommend is using a tool called IIS Crypto. It's a free tool that's out there. You run it. Quite often you click best practices and then change anything that you need there and apply it. And you will have to reboot when you're done. But it allows you to select which protocols you want and what you need enabled and what you don't want enabled, and go from there. So let's go into IIS, or or the Internet Information Services Manager. And from that, if I click on my dev box up here, or your first node in that, there'll be a link to server certificates. And all you have to do here is, now you're here, you can create a self-signed certificate. So to create a self-signed certificate is as simple as giving it a name. So let's just call this CodeRage X. All right. And I have a self-signed certificate for my given machine. And now we need to choose to use it, because the server has any number of certificates. So the default website that I have here, which is, we can have any number of websites, but the default one, let's just choose to set it up. So the first thing that we need to do is let's go over to this bindings, and we're going to select add, and from there we're going to select HTTPS and select that certificate that we just created. And with that, we can close it down, but the problem is now you can hit up via HTTP as well. And say we really want to ensure that this site is not accessible via HTTP. Well, we can remove that here. And another thing that we should do is in the SSL settings, we should require SSL. Now, requiring SSL will give a 403 error if somebody requests this site now without using SSL. Basically, like I said, SSL and TLS are synonyms in this respect. Really, it's us doing that. So let's quickly drop down. Let's just clear this, and let's just use the OpenSSL client connect. And then this time we're going to have our local IP address and hit 443. With that, lots of information, certificate, etc. is there, but you can see towards the bottom I've got my mouse cursor running around it. It's using TLS 1.2 and a variant of the Diffie-Hellman algorithm with AES 256 and a SHA-384 hash. And so that kind of gives you some ideas of how it does. So I can just type get space / and I will have got the front page, first page, the HTML from that server returned to me. So let's show doing the same thing in Chrome. Now, with Chrome and most all the browsers, you're going to have a problem because the connection is not private. And basically it's saying, hey, the reason this isn't private is because it's not from a certificate that we know about. And that is the problem with the self-signed certificate. However, this can be worked around, and it's okay for on a development machine, but it's not something you can obviously have your customers doing. So pay for a certificate if you're publishing this. So I have a certificate. I'm just going to copy and paste this machine name right now. Copy. But if I go in here and proceed, I now see the IIS host. And with that, I can click up here and say certificate information. I can then click on the details. I can copy it out to a file. And in this case, I just leave it as the cert right there. Let's just put it in the keys directory that I was in before. Now that I've done that, I should be able to come in here and run type cert manager.msc. This will launch the certificate manager. I can come into the trusted root, and here's the list of security. certs that I have on my machine, I can import up here and just choose that same the IIS cert, and it's going to place it in the trusted root authorities. And then the problem we're going to run into is if we come back to this, it will always have a problem. So if we paste our full machine name, now it actually recognizes that machine name. And so that was stored in the certificate during the self-signing process. So that in general is how to get SSL. It's pretty simple. Set up an IIS, and now let's talk a little bit about getting an ISAPI DLL. First off, to get an ISAPI DLL loaded, you're going to need to make sure that the ISAPI extension is enabled. So I've gone into the control panel, programs and features, and turn Windows features on or off, and that's what we are on right now on this dialog. If I come into IIS and then go under Worldwide Services and Application Development Features, I need to select ISAPI extensions. And with that, I can hit OK. And it'll take a few minutes, but ultimately we'll have that feature enabled and able to deal with ISAPI. So now that you have an ISAPI DLL, you could have had it from various different sources, like I said, EMS, DataSnap, a REST interface, a SOAP interface. Once you have an ISAPI DLL, you place that into any directory. You want to make sure that that directory does not contain additional information that could be downloadable from the thing. So we don't just point it to a directory that might have additional data such as DCUs, debug information. All that information could be potentially useful to someone if you're able to download that. So the first thing we need to do is we place it in that directory. With that, we go to the website and we right click and add a virtual directory. And in this case, I'm just going to call demo and the C and I just put this on my ISAPI path. So if we're there, we've just created a directory for ISAPI. With that, since we already installed the ISAPI extension module, we need to go up to the main site, or actually on the website here, and choose handler mappings. And with that, we get ISAPI DLL. All right, and with that, we get to choose if we want to edit its feature permissions over here on the right, or we want to select execute. And now that is enabled, but it is not enabled for every specific ISAPI. So you have to now go back up to the main server, and there's an ISAPI and CGI extensions. Those are configured at the server level. From here, I get to add, and I just specify the path to that, and I can just say CodeRage X, and then I say allow extension path to execute, and then I just say OK. And now that I've got that, I should be able to go test it. So we're just going to launch Chrome here, and I have the DLL already loaded, and you can see this. In this case, I had created a SOAP interface, and we're able to see the various endpoints that are there. Basically a simple way of getting there, but if you don't know those few steps, You can try a lot of different things. Now let's talk a little bit about securing this. All right, so what I've done is in that ISAPI DLL directory, I've created 4 different files. I've created a config.ini, a config.txt, a config.xml, and something called settings.config. All of these are just little sample files. If we look in config ini, you'll just see it says the word testing in it. There's nothing special about these files other than we want to try to download them. And the reason for that is we have ISAPI DLLs, but if we're not careful, we could expose our settings via the ability to download. So if we go into the demo here and I type in one of these examples, so let's just do config.txt, you'll notice it says testing because that is actually a file that I have. The TXT files can be downloaded from the website. XML files also, you'll see testing. If I do config, however, ini, I'm going to get a 404 error, and that's expected. And we'll show you how that's set up and why. And then also if we come in here and do settings.config, it also gives us a 404 error. And why are those different? Why is text and XML? Well, by default, ini and config files are not set up to be downloadable. However, that doesn't prevent people from creating configuration files that are not with those names. And if that's the case, you need to do special settings in IIS. That's controlled through the MIME types. And basically, if there is a MIME type for the given file that you're trying to download, it could be potentially downloaded. So notice DLL is present, but if you'll notice, config is not. And if we come down here, ini is not. Okay, so config and ini are not there. But since your DLL is present that way, it is possible that you could set up your settings wrong on your site. So one of the things that I quite often recommend doing is, in case somebody makes a mistake and does not allow your ISAPI DLL starts getting downloaded instead, to be honest, I would prefer a 404 error. I like to remove the DLL from the default website and the DLL config, and those are no longer downloadable, so that this they can no longer get those. But granted, say you were distributing some code and you wanted a DLL and you wanted to put it up for download, you obviously need to deal with that. So those are some thoughts on securing and making sure that the MIME types manage with what you're after. All right, thank you for listening to my session today. The additional information that you might be interested in is the OpenSSL that I needed. You need to download the binaries for OpenSSL to use those. You also have the Fulgum Indy download for just the DLLs that are required are also on this link for the OpenSSL binary. We also have IIS Crypto, which I mentioned during the session. And then all the files and information from this session can be found on my blog, and here are the URLs. If you're listening live, I'd like to turn the time over to questions, and thank you so much for your time.
Hello.
Oh, great. Thank you, Robert, for another great session. Let me get the details slide back up here real quick. There it is. Okay. So there's a few questions look like you already answered here, but we'll go through them here. It says, do you recommend a provider to buy a certificate to use on IIS? I guess, do you recommend a specific one? That's probably what he's asking here.
Sure. Basically, you want to make sure that you're using a provider that's old enough that has the root authority recognized for some time on the OS. if they're a brand new company and they're offering dirt cheap prices, there's a chance that you're going to have clients that won't recognize your certificate, and they'll get the same errors that we were getting during the demo with the self-signed.
Mm-hmm.
We've used Komodo in the past, but to be honest, any of them will work.
And how much does it typically cost to get a commercial SSL certificate?
That's really a good question. Well, every SSL cert comes with a different level of how much they've certified. So an example is if you go to your bank, it might actually list more than just your green. It'll actually list the company name right in the green area where just the lock was, and it's a higher level of certification. So they range quite a bit, $30 to $280 a year. It depends.
Okay.
So yeah.
Are there versions of libeay 32 DLL and SLEAY 32 DLL that are specific to various Indy implementations or versions?
Well, okay. You should use the latest version always with OpenSSL, and that's the Indy Fulgen mirror. I put the link in as an answer here, and you should note that prior versions can and will have security issues.
Okay, yeah, so always use the latest version. It doesn't matter if you're using an older version of Indy or not. Okay. Do you know of a Delphi SSL component that is FIPS 104-2 compliant?
No. The only thing that I know that's FIPS compliant is when we've had to deal with that, the compliancy requires some testing, and that is the OS level encryption. And so we have that in some cases.
Do you know of a certificate authority that provides services for the open source community for free?
I've heard things like that, but I don't know of any.
Yeah, it seems like I've heard.
And I do know that there's projects right now that are afoot that are free SSL certificates for web servers that are trying to make their way out. But I haven't seen any of those come. They were announced a year ago, and none of them have actually really started producing, to my knowledge. They might by now, but it's something that's not there yet. Yeah, Let's Encrypt.
Yeah, that's the one that I remember hearing probably about the same time you're talking about that they were. I hear Global Sciences, they have free SSL for open source.
And so
anyway. Okay, if there's any other questions for Robert for the presentation he just provided here, go ahead and enter it in the question area here on GoToWebinar, and we'll get them answered for you. A lot of good information here between these two sessions, Robert. Thank you for putting these together.
So one thing I wanted to point out that I didn't cover in the recording is if you're dealing with EMS, it's kind of recommended to, if your production issues, put it in IIS as an ASAPI that I covered quite well. But if you choose to have it as a standalone server, you can still use SSL. You just have to open up the EMS INI file and change. It has the certificate entries, quite like I did with the code for the app. You just need to specify those certificate entries and in the INI, and it works.
Okay, that's good to know. Okay, well, I think that's it for questions, Robert.
Well, thank you.
Big thank you for all that you do and for these sessions.
Well, we hopefully these will be useful to somebody in the community.
I suspect they will be. Oh, here we got some more questions just came in. With
Oh, sure.
TNet HTTP client, how to apply the key?
Okay, so the net HTTP client, unless you're requiring a client-side certificate, you don't need a key, because client-side, for the most part, doesn't need a certificate. There are situations where it can be set up and required, and I don't believe that is supported by the net HTTP client. But then, I've never looked. It's not a common thing to see.
I think it does have an event that fires for a client-side key request or something like that. That sounds familiar.
It does, and that doesn't surprise me. But it's not a common need. So for the most part, your net HTTP client will work with HTTPS. Set up servers with nothing. It'll just work on every platform that Embarcadero supports.
Yeah, it also has.
It's really nice.
If I remember correctly, it has two events. It has one that fires for client-side certificate, and the other one that fires that says that the OS couldn't validate the server certificate, but it gives you an opportunity to validate it. So that way, if you're connecting to like a self-signed certificate or a certificate signed by a certificate authority that doesn't have root authority, then you can still perform your own validation.
Okay.
So here's a question. What is an intermediate certificate?
Okay. All right. So you can get a certificate as you can set up what's called like I did in the demo with a certificate authority or a root certificate authority. And then with that, you can sign yet another certificate authority to go. So there's yet another file that's an intermediate certificate authority, and then that one is typically used to sign the end server one. And with that, if you think about a company like VeriSign or anybody that sells SSL certificates, it's in their best interest to never let their root key go away. So I suspect it's not even on the network. I suspect their machines that contain that root key are physically not connected to any internet. If they are, they're putting their entire business at risk. Instead, they sign an intermediate key, and that one may be on the network and usable. But then if they have some type of breach and that key is compromised, it's only those that have been signed by the intermediate, and you can revoke it versus the root. So the root you want to keep as secure as possible. So it's just kind of a multi-phase, and you can have multiple intermediate certificate authorities doing this.
So they probably rotate through intermediate certificates like on a regular basis, probably.
Yes, so that they can. It's a business safe practice for them.
Yeah, that makes sense. Interesting. Okay, well, I think now we're done with the questions.
Okay.
There was one more about where Apache documentation can be found, so I sent them a link to apache.org/docs.
Sure.
Oh, now
here's one more.
Another question. How certificates are used to sign usernames and passwords like in web services to generate access tokens?
So access tokens are implemented very differently depending on their usage, and sometimes they're not certificate based. So it all depends on the nature of what you're after. Quite often, an access token is actually dealt with as an HMAC hashing algorithm instead, which Delphi does support if you look at any of the hashing algorithms. Okay, you mean an algorithm technique. So I'm hopefully I'm heading down the right path for you. But HMAC is definitely one of the ways that that's been dealt with, and it's really common across most of the REST service providers, and it's really a simple call. If you just go read up about HMAC and how it works on Wikipedia, you'll find out more information than you need, and then you'll go find out that it's a one-line call in Delphi to make it work. So then you have to just choose to intercept the data and how you're going to put it into your protocol.
Cool. You know, there's a trick I learned on Wikipedia, by the way. Over on the left-hand side, it lists all the other languages that it's in. And on some articles, there's a language entry that says simple. And if you go to that one, it's a simplified version of the English Wikipedia. And especially, yeah, especially when I'm reading encryption ones, I'm like, I don't know that I understand this. And I go read the simplified one. I'm like, oh, now I understand it. And then I can go back and read the full one, and it all makes more sense because it has that simplified thing in there. So yeah, it's not on every article, but on some of them it is. And it's really useful when it's there.
Okay.
It's not quite kindergarten level, but it's certainly more approachable for some of the more complicated ones. So here's a question: how to install an intermediate certificate on an AWS EC2 server using Node.js app as a server, and a Delphi iOS client using REST?
Okay, so the question really depends upon the OS, because an EC2 server can be multiple different versions of OS. Given the fact that they're running Node.js, it could be Windows, but it probably is Linux.
Yeah, he said it's Linux.
Oh, yeah. Funny. He answers. He asked that same. Okay. The answer, I don't know. You need to look at looking at the Linux, how to install a certificate authority on a Linux server, and there will be documentation for that. And that it's not something that's specific to Apache or Node.js. It's actually most likely the OS that you're concerned about.
Okay, hopefully that is good for that answer your question, David.
I hope that's as much as I know.
So I'll put a link in the chat window here. This is the Wikipedia Simple English translation for RSA encryption. If you've ever tried to install RSA encryption, it's kind of complicated, but this makes it understandable. At least it did for me. It's just simple.wikipedia.org/wiki/whatever it is they're looking for. So he's asking how to change the base URL of Delphi apps for interweb or web broker. For example, from localhost to www.mywebapp.com.
I don't know. I've never even thought of that. I thought that it just worked. The problem is not usually. There is an issue that I've been meaning to look into, that for some reason with an ISAPI application, when you go to visit like the WSDL, it tries to visit an HTTP version. And when we've turned that off on servers, obviously it breaks and it pretends that it's not responding. But it doesn't matter what the URL is. It seems like Delphi's always responded, but it seems to be prefixing for some reason HTTP on those requests, and it really doesn't need to. So I've been meaning to see if there's an option or how that works, but I really don't know on that. But as far as domain name changes, it just works.
Okay. He says why?
So if you change your web server config to respond to a different domain, so that's actually an IIS, doing that, your ISAPI or web broker application will respond on that domain perfectly. The only thing that I have seen is web services still work fine. It's just the web interface that comes up when you visit an ISAPI DLL is the only problem that I've seen, and I'm not even sure that it's a bug. It could be that I just don't know how to use it, and I just haven't bothered with it yet because it's not I work around it.
So is there a way to hide the port number then?
No. Once you use the standard port, if you use a standard port, 80 or 443, depending on if then the port number will go away.
Yeah.
But there is no way to hide the port number because it's part of the protocol. It's not something designed that way. You just have to be listening on the correct port.
Okay. All right. Well, thank you, Robert. It's 5 minutes to the top of the hour, so we need to get on to our next session here.
Sure. Hey, thank you again.
Yep.